deployments. We want to reach an automated end state. The goal is a pipeline where pushing your code to the main branch on GitHub automatically builds, tests, and deploys your application directly to your live server. To build this, you need 3 baseline components: a GitHub repository containing your code, a Voxfor VPS with SSH access, and a sudo-capable admin account. However, automation introduces risk if the environment is exposed. Before we move a single line of code, we have to build a foundation of rigorous, production-grade server hardening. Step 1 is separating your deployment processes from your administrative power. Create a dedicated, unprivileged user account specifically for deployments. You should never run automated web deployments as the root user. For this new user, generate a modern ED25519 SSH key. This provides the cryptographic foundation for your server to communicate securely. As you can see in this server configuration file, we then explicitly disable password authentication. By setting password authentication to no, we force the server to only accept key-based logins. Next, apply UFW firewall rules to restrict incoming SSH traffic. If you have a static IP address, lock down port 22 so that the server only accepts SSH connections originating from your specific admin IP. For the server to pull code, we use a read-only deploy key. A deploy key is an SSH key attached directly to a single repository. Because it is read-only, it prevents a compromised server from pushing malicious code back into your codebase. Take the public half of that key and add it directly to the deploy keys section in your repository settings panel on GitHub. Finally, manually add GitHub's official host key to your server's known hosts file. If you skip this, the automated connection will stall out waiting for a manual verification prompt. By locking down the network and strictly separating privileges, we guarantee that even if your live web application is compromised, the attacker is trapped within an unprivileged user space without root access to the machine. With the server secured, we need to structure the files. Directly overriding live application files during an upload guarantees broken states for your end users, because files arrive sequentially over several seconds or minutes. A master releases folder holds isolated, time-stamped application versions. A current symlink acts as a traffic director, routing visitor traffic to the newest release. New deployments upload quietly into a new folder. We then change the symlink target, instantly swapping to the new code. Separating the file upload from the live file swap is the mechanical secret to near-zero downtime. There are 2 main ways to trigger the swap. Method 1 uses GitHub Actions. This is the cleanest default because it keeps CI/CD logs, artifacts, and orchestrations centralized inside GitHub. This UI dashboard lists the 5 specific server credentials you must securely store as GitHub secrets: the host, port, user, SSH key, and known hosts. GitHub uses these to authenticate securely. You instruct GitHub on what to do by creating a primary workflow YAML file, which lives inside the .github/workflows directory of your repository. Inside that file, you add a concurrency step. This strictly prevents 2 production deployments from running at the same time, ensuring multiple developers don't accidentally collide and corrupt the live folder state. You should also pin any third-party actions, like action/checkout, to their full commit hashes. This prevents supply chain attacks if a third-party action is compromised and updated maliciously. By letting GitHub act as the control tower, you prevent your VPS from being bogged down by resource-heavy application builds. The server stays lean and focused entirely on hosting the live traffic. Method 2 relies on GitHub Webhooks. You use this if your application must compile system packages or run local database migrations directly on the target server environment. In the GitHub UI, configure the webhook by pointing the payload URL to your VPS domain and mandate an application/JSON content type. GitHub fires a payload at your server, caught by an Nginx reverse proxy. It is a critical security error to validate a payload already mutated by backend frameworks. Instead, validate the exact original bytes against the HMAC signature to safely execute the build. While webhooks shift the computing burden to your local machine, they provide an air-gapped build environment. You never have to give an external CI/CD service SSH access to your server. No deployment architecture is truly production-ready until you test the unhappy path. You need to know exactly what happens when things break. To verify the system, intentionally push a broken release to your repository or artificially trigger a deployment failure over SSH. Watch the pipeline execute. The bad code uploads, the symlink swaps, and the live application immediately fails its health checks, dropping offline. Because we kept the old release folders intact, fixing this requires a single terminal command. You manually repoint the current symlink back to the previous stable directory. This atomic file system switch restores the live site in milliseconds. You bypass the need to revert Git commits, wait for a pipeline to rebuild, or transfer files again. This is the ultimate value of a proper deployment pipeline. Developers can push code with total confidence, knowing the infrastructure securely handles the delivery and reduces a potential catastrophe into a 5-second fix.